Hi guys, this is our Unit 5 Set 1 notes. You should have these notes already in your possession. So we're starting a new unit here and we're looking at quadratics. So we can see that we're starting with a quadratic written in standard form, and so this should look similar to your opener on Monday of this week. And it says factor this, and so we should use trial and error here. And if I use trial and error, I can see that it's going to factor into x minus 4 and x plus 2. So then it says solve the following. Remember, solve means find the roots, zeros, solutions, and x-intercepts. So in order to solve, you always let y equal 0. And I'm going to go ahead and use the factored form here. And again, I'm showing that I know what it means to solve. And in order to solve this problem, I know from third grade math that anything times 0 is when I get an answer of 0. So I use zero product property, which means I get solutions of 4 and negative 2. Now, what does that tell us about the graph? Well, that tells us the x-intercepts. So we know that we have an x-intercept of 4 and we have an x-intercept of negative 2. So what else do I need in order to graph this parabola? Well, I need the vertex, and your vertex is always going to be located in the center on the axis of symmetry. So the axis of symmetry, you're looking for what's in between negative 2 and 4. Well, that would be 1. So we now have located our axis of symmetry. Our axis of symmetry is the line x equals 1. And not only is that the axis of symmetry, but that will be where the x value of the vertex is located. Now let me come to the side. If you know an x, how do you find a y? Well, you plug that x in. You can plug it into either your factored form or your standard form. Personally, I like the factored form. So I get, let's see, negative 3 times 3, so negative 9. And yes, this is enough to graph. I really just need 3 points. But another thing that I can find is the y-intercept. So to find the y-intercept, you always plug 0 in. Again, you can use factored form or standard form. It makes no difference. And so when I plug that in, I see that I'm going to get 0, negative 8. Now actually, that produces another point. Parabolas are symmetric. And so, since 0, negative 8 is 1 unit away from the axis of symmetry, I will have 1 point on the other side. Those are called corresponding points, by the way. And not only are these 2 points corresponding, but my x-intercepts would be corresponding as well. So I have my y-intercept. I did write that as an ordered pair. I have enough to graph this now. So does this graph have a maximum or a minimum? Well, it has a minimum. It has a y value that there's no y value less than that. So it's a minimum, and there's a correct way to write this. Our minimum is negative 9, and it occurs at x equals 1. So we're going to take this exact same problem, and we're going to look at it a different way. So that method, we found the x-intercepts and went from there. Method 2, we're going to use what is called completing the square. And so completing the square, you've actually done this before. What that means is that we're going to take x squared minus 2x, and we're going to add something to that quantity, and that something is going to make a PST, a perfect square trinomial. Now, why do I have a blank on the other side as well? Well, if I add something on the left to balance, I will have to add it on the right. And so again, this is a perfect square trinomial. So a couple things to remember about a perfect square trinomial. When you factor a PST, the 2 factors are exactly the same. So I almost in a way work backwards. I think about what would give me x squared. Okay. What would give me a negative 2x in the middle if I distributed? Well, you'd probably tell me a negative 1 and a negative 1. So then I can take what my factored form is and work backwards to figure out what that means I need to add on this side. So let's just double check. X times x is x squared. Negative x and negative x is negative 2x. Negative 1 times negative 1 is positive 1. I'm going to add it on the other side as well. So I almost have this, excuse me, in vertex form. I'm going to write x minus 1 times x minus 1 is x minus 1 squared. And then I'm going to subtract 9. So not only is this vertex form, this is also a form where you can use transformations. So for example, I would go right 1 and down 9. Now what points would I take right 1 and down 9? Well, your parent function is y equals x squared. So remember that's 0, 0, 1, 1, negative 1, 1. If you wanted to take 2, 4, you could. And this is the same problem here, so you would get the exact same graph. So let's actually look at number 2. So number 2, as you can see, is in a form where you can use transformations. The transformations here would be right 3 and down 4. So I'm going to take 0, 0. I'm going to go right 3, down 4. I'm going to take 1, 1 and go right 1, 1. Let me put my pencil in the correct place. I'm going to go right 3, down 4. Now I do know this graph is symmetric, so I'm going to draw my axis of symmetry in. I automatically know the corresponding point. To just help us get that parabolic shape, let's take 2, 4. Right 3, down 4. All right, so our vertex is at 3, 4, negative 4, excuse me. Our axis of symmetry is at x equals 3. This is a minimum y value, and our minimum is negative 4 at x equals 3. Domain is always left to right, and so it's all real, or of course you can write that negative infinity to infinity. Range is down to up, so we can see that we're starting at negative 4 bracket to infinity would be our range. So as I look at this problem, we're going to write it in standard form. Well, to write it in standard form, we need to know that x minus 3 times x minus 3 is what it means to square something. Don't do my pet math peeve and tell me it's x squared minus 9. Because you know that it's x squared minus 6x plus 9. And then I need to subtract 4. So standard form would be x squared minus 6x plus 5. And notice how I did use good notation. That's equal to f of x. So now let's factor that standard form, and that's going to be trial and error, isn't it? X minus 5, x minus 1. I can use that factored form to set equal to 0. Again, that's what it means to solve, is you're letting y equal 0, and then I use zero product property. So our solutions are 5 and 1. All right, so let's look here at number 3. So as I look at number 3, again, there's going to be 2 ways to graph this problem. So one, I can see if it factors, and it does. It factors into x plus 7, x plus 3. I can use that factored form to solve. So according to the zero product property, I get negative 7 and negative 3. Then I find the middle. That's where my axis of symmetry is. Not only is that the axis of symmetry at negative 5, but it's also the x value of the vertex. If I know an x, I can easily find a y. So I can take x and I can plug it in. And again, you can do standard form or factored form. I've already mentioned I prefer factored form. So negative 5 plus 7, negative 5 plus 3. That's going to give me 2 and negative 2, so negative 4. The y-intercept, let me come over here and make sure to show my work. I'm going to plug 0 in, and this time I'm going to plug it into factored form. So I get 0, 21. Which would be way up here, and that does make sense in relationship to the rest of our graph. Not only do I know 0, 21 would be a point on the graph, but I know its corresponding point. So this is 5 units away from the axis of symmetry. I would then have negative 10, 21 as well. And so let me sketch the graph here. This is, again, a minimum y value, so it's negative 4 at x equals negative 5. And so let's make sure that we can write this in vertex form. So again, vertex form is really just a form that you can use transformation. And to get that form, you're going to form a perfect square trinomial. So I, once again, think backwards. So I think about, to get x squared, I need x and x. A PST means your two factors are exactly the same. So what would give me a 10 in the middle? Well, I would need a 5x and a 5x. Which means I would need to have 25 in this blank. So x squared plus 10x plus 25 is what factors into x plus 5 times x plus 5. If I add that on the left, I have to turn around and add it on the right, which means we get x plus 5 squared. I'm going to go ahead and move over the 25, so minus 4 will equal f of x. And so those transformations would be left 5 and down 4. And does that correspond with the graph? Yes.